Hello everyone. In this video, we're going to cover another advanced topic related to functions, specifically pass by reference. So far, when we've been calling functions, we've been using pass by value, even though I've never actually said we're using pass by value. So we're first going to review what we know about variables and how values are copied into variables, and then we're going to learn about reference variables and learn that they could be an alias for another variable. Then we'll pull all that together and talk about the difference between pass by value and pass by reference when we call functions. So let's head over to the notes. The warm-up task that I've specified today is actually the same warm-up task as our last video where we were working with advanced prototype fun. It's good to kind of rework the same problems so that we get used to them. This time we'll take a slightly different approach though to our rolling die so that we can utilize pass by reference, whereas before we were utilizing roll die and display roll result for function overloading and default arguments. So let's head over to the VM and open up a file called referencefun.cpp, and let's code up definition, prototype, and call for roll die, and definition, prototype, call, and display roll result again. All right, so we finished our warm-up task. We've got prototypes, calls, and definitions for roll die and display roll result. Now, we're going to review variables. It'll be a good review and also kind of set the stage for learning about a specific type of variables called reference variables. So let's say I have code that looks like this. A variable is a named location in memory that stores a value. So when this code executes, somewhere in memory, there's a location called x that stores the integer 10. Now, let's say we have another variable, and it's called y. I didn't initialize y, so let's just put a question mark in here. We don't know what y stores currently. Then let's say we execute another line of code, which is y is assigned x. what happens on this line of code is the value stored in X is copied into the value stored at Y. So whatever was at Y previously is now overwritten with 10. Now, the moral of the story is X and Y are two separate variables that each refer to a separate location in memory. Now we're going to learn about something new, something called reference variables. A reference variable is an alias for another variable. In this example, X and Y refer to two separate locations in memory. A reference variable is a variable that's going to be an alias for another variable, specifically that other variable's memory location. So let's see an example. Let's say here I have int X is assigned 10. So I have 10 here stored in a location in memory called X. Now I have int Y, but I'm going to put a special symbol next to the data type on Y. It's an ampersand, and this is going to denote that Y is not a normal variable. It is a reference variable. And Y is a reference for X. So now I draw Y. It does not get a memory location of its own like it did in our previous example. Instead, I'm going to draw an arrow that shows Y is an alias for X's memory. So now I can use Y or X to access and modify this value 10. For example, let's say I have Y is assigned 5. Y doesn't have its own memory location in order for us to overwrite a value with of 5. Instead, just as if we were using X, Y is assigned 5 is going to overwrite this location in memory because both X and Y refer to the same location in memory. Y is just an alias for X. All right. So what does this have to do with functions? Every time you make a copy, as in the example we saw here, it's very expensive. Memory has to be copied bit by bit in order for it to be transferred from one location to another. So let's take a look at how values are copied when we pass in an argument to a function. Let's say we have a really simple function called f. This is our really simple function for f. All it does is accept an integer and print it out. So when we call f passing in x here, we have a local variable of, let's say this is main, called x, and it stores 10. We pass the value of x into the parameter y, and its value is copied. Now, there's a local variable in the function f called y, and it stores 10 because there was this copy that occurred here. There are two different locations in memory. X is local to main, y is local to f. If I had a line of code here, like y is assigned 100, this assignment overrides this memory location. Y now stores 100. This memory location, local to main, called X, is unaffected by this assignment because these are two completely different locations in memory. This entire process of calling a function, copying the value of a variable in an argument into the value of a variable that's a parameter, emphasis on the copying, is called pass by value. Two things to note about pass by value. First off, in pass by value, you are calling a function, passing an argument in as input to be copied into a parameter. Emphasis on the copy. That value is copied into a different location in memory, two different locations. When you change a parameter's value, such I have here, that only updates the parameter variable's value. It does not change the argument variable's value. X is unaffected when I assign y to 100 because this value of 10 has been copied into a separate location in memory. Y refers to this location in memory. It is unconnected to this location in memory. Now, this is how we've been calling functions this entire time, up until now. We just learned about reference variables where we can have another variable that refers to the same location. So now it's time to see an example of pass by reference. All right, I'm going to declare another function. This function is going to have a parameter y that is a reference variable because of this ampersand here. This will also be a very simple function. Just print out the value of y. Okay, so back over to our code in main on the left side of the board here. I declare a variable x, I assign it 10. Now I'm going to call the function f, also passing in x, just like I've done in the above example. The key difference here is, in this case, f accepted an integer. In this case, f accepts a reference to an integer. So the value of x is not going to be copied into a new memory location in y. Instead, there is going to be a variable y that's local to f, but it is going to refer to this location in memory, which is also referred to by a local variable of main called x. So now, when we print out y, it's not referring to a memory location that's local to f. Instead, it's going to go access the memory location referred to by x that's local to main, and it's going to print out 10. Here's the most important part. I'll write it in green. Here, if I have y is assigned 500, this overwrites the 10 in x with 500. Because y is an alias for x. So that brings us to pass by reference. All right, pass by reference. No copying occurs. The reference parameter can change the argument's variable value. So there's the key differences between pass by value versus pass by reference. Pass by value, think copy, 2 different locations in memory. Pass by reference, think no copying, instead alias. And there's 1 location in memory such that the reference variable is an alias for. So in this way, you have functions that can change the state of variables in other functions, which can make things a little bit tricky to debug, but it also makes code really powerful. For example, we can only return 1 value from a function, right? We can return an integer, we can return a double, we can return a string, but with reference variables, we can essentially return as many values as we'd like, right? We could have int y and z here, and we could compute values for, let's say, 2 different computations, store the first result in y, store the second result in z, and then the calling code can use those results. Note that the function's return type is still void, but this function would essentially be able to return 2 values or more values if that function or that programmer would like. Okay, so let's see this in action. Let's head over to the VM. Let's write a function that rolls 2 dice. We'll use reference variables to return the 2 dice results. So we'll have void roll 2 dice. We'll have a reference to an integer to return the first roll result, and a reference to a second integer to store or return the second roll result. So these ampersands here denote that we're going to use pass by reference instead of pass by value, such as we have up here. So we'll simply assign to roll 1 the return value from a call to roll die. We've already written that function, so we should reuse it. And we'll do the same thing for roll 2. Oops, this should be void. Note that there is no return value or return statement, but main will be able to use these 2 roll results via the reference variables. Okay, so now we need to call roll 2 dice. So I'm going to need a second variable. I'll call it role2. So we have role and role2 in main. We have role1 and role2, the parameters that are reference variables in role2 dice. Okay, let's make a note here. Role1 in role2 dice is a reference for role in main. Role2 in role2 dice is a reference for role2 in main. So even though I've used the same variable name role2 in main and role2 in role2 dice, don't let that be confusing. Those could be two separate names, as I've done here with role and role1. This role2 is local only to role2 dice, and it refers to the local variable role2 that is local to main. So now let's run this. Okay, so when I'm throwing my 2 dice in role2 dice, I'm getting a 2 and a 4, 2 6s, a 2 and a 6, a 1 and a 6, a 3 and a 5. Now let me show you, even to explain more, that no matter what I set role1 and role2 in roll dice to be, that's going to change the values of role and role2 in main. So let's say I always set this to be 100 and I always set this to be 500. Even though role1 and role2 are local variables of role2 dice, they are references, they are aliases for role and role2 in main. So we can effectively update memory of main via role2 dice because we've used pass by reference. And there you go. You see that role and role2, when we print them out on lines 24 and 25, are now always 100 and 500 because we use their references, role1 and role2, to set their values in role2 dice. So to wrap up, I'll just draw a little diagram showing the memory map for this program. So in main, we have role and we have role2. And then in role2 dice, we have role1 and role2. Role1 is an alias for role, and role2 is an alias for the role2 that belongs to main. Reference variables can be a little confusing to work with at first. I highly recommend making these memory diagrams so you can see the relationship between them when you're using reference variables. Reference variables are quite powerful. Like I said, you can use them in order to return multiple values from a function. You can also use them to make your code more optimal so that you're not copying large amounts of memory. So here, copying values can be inefficient for large values and or several arguments. But we can use a reference variable and pass by reference in order to avoid that really inefficient code of all that copying. Okay, so pass by reference you can use by choice when you think it is fitting for working with whatever function you're writing. However, you will have to use pass by reference in some situations. For example, if you're working with a library that has prototypes for functions that require reference variables to be used, then you will have to use reference variables as well. So let's take a look at a topic that we're quite familiar with and see how, in some cases, we have to use reference variables. When working with ifstream and ofstream variables, you cannot use pass by value. You have to use pass by reference. So let me show you an example. Let's go ahead and include the fstream library. And let's add a variable of type ofstream for an output file. What we'll do is just write out the results of roll and roll2 to the output file, but we'll do the actual writing out of the file in a separate function other than main. So let's open a file. We'll just call it rollresults.txt. Now let's call a function called write_roll_results. We'll pass in output file because we'll have to use output file in order to have a file stream to write the results to, and roll2. So let's add a prototype. Void write roll results, passing in an ofstream variable. This has to be a reference variable, but I'm purposely not going to make it a reference variable so you can see that the code won't compile. And then an integer and an integer. All right, in the body of write roll results, we'll simply use output file and the stream insertion operator in order to write out the results. All right, so let's try and compile this. We're going to see that it doesn't compile. It says some strange error, line 31 here. Use of deleted function. Okay. ofstream. Okay, this is kind of hard to debug. But we do see right here something about basic ofstream, constant basic ofstream, ampersand. Okay. Then we see something wrong with initializing argument 1 of write roll results. Okay, so we know there's something wrong with argument 1. We see here something about deleting some function, but we've got a reference variable to an ofstream. So this is kind of hard to debug, but what's really happening is we're required to use pass by reference when passing ofstream and ifstream variables. So if we add an ampersand to the end of our ofstream in our definition, and an ampersand to the end of our ofstream in our prototype, and then try and compile, it now compiles. So here's where we don't have a choice. We've got to use pass by reference. And one of the reasons why ofstream variables and ifstream variables have to be passed by reference is because there's state associated with the ofstream, such as the file cursor, right? We don't want to be making copies of where our file cursor is at when processing our file, because then we'll get some unintended results. So usually data types or classes or objects, which you'll learn about later in your computer science career, that have side effects, you'll typically want to not make copies of those objects. You'll want to use pass by reference. Also, the ofstream variable could be quite large, so in order to be more efficient, we want to use pass by reference instead of making a copy. All right, so let's run it. And let's quickly open up our roll results.txt. And there it says you rolled a 100 and a 500. So it looks like we were successfully able to write out our roll 1 and roll 2 values to file. So that wraps up our conversation on pass by reference. Be sure to keep practicing with it, make up some examples, or perhaps return to some of the previous programming assignments or code we've written and see if there are opportunities where you could use pass by reference instead of pass by value.